Welcome. In this video I'm going to show you how you can analyze a single ordinal variable using R and my stikpetR library. This video will focus on how to obtain the output, not so much on how to interpret that output. I'm using Jupyter Notebook, but the code should also work in, for example, RStudio. I'll leave a link to this Jupyter Notebook in the description on my website, and the links in this Jupyter Notebook are actually for my Python library, but they link to the help files, but they should be the same for R. On my website there is also a PDF for the R functions. So what I'm going to do is to analyze an ordinal variable. I'll first create a frequency table, then convert that to a stacked bar chart, so to have a visualization, determine the median as a measure of central tendency, and a measure called consensus for the dispersion. Then use a test, the one sample Wilcoxon signed rank test, to see if it's significantly different, if the center is significantly different from, in this example it will be the neutral option, and then as an effect size measure I'll use a correlation coefficient. For each there are some alternatives. I'll quickly show those as well, and they're in the notebook as well, and I have functions in my library for that as well. Of course, the first thing I'll need is my own library. You can use remotes, install GitHub, because it's not available on CRAN, so you can't just use install packages and then my stikpetR. I have already, of course, installed it, so I don't need to run this. And I'm going to just use my library stikpetR. So once you've installed it, you can run it just as any other library. Next, the example then. I'll need a data file for that. I have one on my website, so I'm going to load it in from the URL. And in there is one field called teach motivate, which was about asking students if they felt this teacher was able to motivate them. So I'm going to be using that as my example data. Notice the double brackets here. That's important because otherwise those functions of mine might not work. And I'm also going to, because it's actually going to just have text like fully disagree, someone disagrees, someone agrees, someone else disagrees, etc. So I'm just going to list them all in order so that we can use that later as well to let R know that we're actually having a specific order here. The first thing I want to see is then a table out of my data. So to get just a quick first impression. It shows, I can use the tab frequency function for that. I feed it the data and the order. And as you can see, it nicely is in order. There is a difference between percent and valid percent, and the difference is that percent also includes the missing values. They're not shown, so these won't add up to 100%, and the difference will be, of course, those who didn't answer the question. These should add up to 100%, and it also shows the cumulative percentages. I can immediately see that 76% was neutral or went for disagree or fully disagree, and even 54% was on the disagree side. Now, it might be easier to actually visualize these results, so a basic stacked single bar chart can be done with VI for visual and then bar stacked single, and that gives us then a quick visualization, and similar as from the table we can see the same results. It seems that about 50% of the students are on the disagree side, red and, well, let's call it dark orange. But we can actually also see the 50% by determining the median. It's the value at 50%, and by using ME median for measure and then median, and it nicely shows that disagree was indeed the median. Now, usually they also want then a measure of dispersion. The interquartile range is quite often used, but that is based on quartiles, and especially if there are only 5 options, I wouldn't recommend using it. So I sought a long time and finally found a measure called consensus that also, I think it's always between 0 and 1, so there's quite some variation actually with 0.43. Now I'm quite interested to know if it's also significantly different from the neutral option, the 50%. So is there a significant number of students who actually went for the disagree? the neutral option would have been the fifth out of the 5, the middle one. So if I use my basic function, the Wilcoxon signed rank test, one sample, and I don't specify what I want to test, the test value, it will take the mid-range. So I can run this test, and in this case it tells me quite a lot of information. It gives me the number of ranks that were actually used, so the sample size as it were, what was actually tested, so in this case 3, which was fully disagree was 1, disagree was 2, and neutral was 3, so indeed testing the neutral option. The W statistic, a Z value, there's no degrees of freedom because it depends on which test you're actually using. But this is the most important one, that p-value. It's 0.005, so that's below 0.05. Notice the 2 zeros after the decimal. And usually people would use as a threshold 0.05. If it's below, we reject the assumption. The assumption in this case was that the median would be 50%, the neutral option in the population. And that's therefore rejected, so it was indeed significantly different from the neutral option. Now, usually they want also an effect size measure. One I could find was the correlation coefficient, but not the Pearson version, so I'm calling this Rosenthal because it was the earliest reference I could find to it. It requires the sample size, which we can simply get from this test results, the Z value, which is the statistic from this test result, and then we can feed that into the function I made for it, and it should give us that correlation coefficient. We might be able to use Pearson's correlation coefficients rules of thumb for this, and that would classify this as a moderate effect size. And also here's the reference for that. That kind of goes over all the steps for analyzing a single ordinal variable. Alternatives, for the visualization you might want to use a dual axis bar chart. So that's basically a bar chart but then with a cumulative percentage in there. You might have as alternative measures quartiles, which are at the 25 and 75%. Actually the second quartile would be the median, and the zeros would be the minimum, and the fourth would be the maximum, so it's a bit strange that you have 5 quartiles. I also actually have a function for quantiles, then you can specify how you want to split up the 100% data. As mentioned earlier, there's also some measures for dispersion that are based on those quartiles, so I put them all under quartile range. If you don't specify anything else as a specific measure, it will just calculate the interquartile range. If you use stikpetR, it will give you the semi-interquartile range, which is the same as qualitative deviation, so the same measure there. And you can use mqr, which was for mid-quartile range. Yeah, mid-quartile range, and there is the result of that one. Alternative tests, you could have a look at how many scores were below the hypothesized middle option and how many were above, and then perform a one sample binomial test. That's then a sign test. It can be performed, there's no issue, there's just one simple function for that. If it excludes therefore the ones that are tied with the hypothesized value, so all the neutral scores in my example would have been simply ignored. So if you want to include those as well, you can actually use a trinomial test, which will therefore give a slightly different result. It will show how many were above the middle option, how many were below, and how many were tied, and of course the p-value for that. As an alternative effect size, you could use the rank biserial, one sample, or you can use something known as a dominance score. And from the same website where I actually found this dominance score, they also refer to a VDA-like measure, so I also included it in here. Alright, and that is in just under 10 minutes how you can analyze an ordinal variable using my stikpetR library. I hope this was helpful, and thank you for watching.